Hello, my friends. Welcome to DevNation. You might have noticed that I have a different background today because I'm not at home anymore. I'm on the road, and actually today I'm streaming live from San Jose, California. I was in San Francisco yesterday, and I'm streaming from my mobile phone. So fingers crossed that everything will be well. And today's guest is not a new guest. Actually, Bernard was here before. So we already know that he always presents great content. So I'd like to invite to the stage our friend Bernard. Hello,
Hi.
Bernard.
Hey,
Yeah,
Edson.
how are you doing? Do you have some good IoT, Edge, and Kafka stuff for us today?
Yeah, I think I have a nice demo to show you guys. So let's uh, let's get it started. Okay.
Okay, yeah, I know you worked super hard for this to happen. So we're super eager to see what you have for us.
Okay.
And
Thank
without
you.
any further delay, oh, sorry.
Sorry.
Okay. No,
Yeah.
I thought you were saying something,
No.
but
No. So you need to share my screen, right?
yes. So
Okay.
let's start the show. So today, live from Belgium and San Jose, California. Welcome to DevNation.
So hi. Welcome. So I'm Bernard. I'm a technical marketing manager in the Cloud Services BU in Red Hat, and today I'm gonna talk, but mostly show, a IoT scenario with OpenShift Streams for Apache Kafka. Okay. So the agenda is I've got some slides about Apache Kafka just to set the scene. I'm going to go fairly quickly through it. I'm going to explain the use case, and then the bulk of the time, at least half of the time, we spent on actually demoing how several pieces of technology fit together to create something interesting. And then at the end, we might have some time for questions. So, what is Apache Kafka? It's a distributed system designed for stream processing, so and handling continuously streams of data, and it's highly available, very scalable, fault tolerant system that basically powers stream processing applications. So there are lots of use cases for it. So actually, Kafka is taking the IT world by storm at the moment. So some use cases are like high performance data pipelines, streaming analytics, data integration when you need to move large quantities of data from one system to another, for instance. It's becoming more and more the de facto event bus and event driven architecture. So every time you need to like ingest and process large amount of data, Kafka can be used. So today we're going to use that in a IoT scenario where basically we have IoT devices that are producing streams of data that in the end are going to end up in Kafka, and from there we can do like real-time analysis and other interesting stuff. So if I want to try to explain Kafka on one slide, that would probably be something like this. So you have concepts like brokers, topics, partitions, producers, consumers, etc. So Kafka is a distributed system by definition. So that means a Kafka instance generally consists of several brokers. So in this case, there are three. So which gives you like fault tolerance baked in from the start. So everything within Kafka is built around the notion of topics. That's where actually the data flows in and out to from topics. And topics consist of partitions. So one topic is typically divided in one or more partitions. And those partitions you can have topics of hundreds of partitions. When producers, what you see here on the left side, they produce messages or they send messages to Kafka, they actually send messages to a topic, and those messages or those events end up into a partition of the topic. Okay, so basically all the messages of your producer will be distributed over the several partitions. Oh, what I also didn't mention, the topics themselves are typically replicated over the different brokers. Actually, the partitions are. So if you have three brokers and your topic has a replication factor of 3, that means that everything that's in the topic will be replicated over your brokers. So that gives you like high availability. you could, in that kind of scenario, lose 2 brokers without losing any data at all. Consumers consume from topics. Actually, they consume from partitions. And that's also where things get interesting. So if you have one consumer in a consumer group that consumes from a topic, that consumer will actually consume all the partitions, okay? But when you scale out your consumer in that consumer group, let's say you have a topic, you have 3 consumers, you have a topic of 15 partitions, that means that now every consumer will consume from 5 partitions. So you can scale out in that scenario, you could scale out your consumer to 15 instances. So any of those instances would consume from 1 partition. So that gives you scalability on the consumer side and allows you to do massive parallel consumption of data. Okay, so that is one of the things that gives the scalability of a system like Kafka. So obviously, to interact with Kafka, there are APIs. So producers and consumer APIs, that's all about consuming and producing. There is an admin API that can be used to inspect your brokers and other Kafka objects and to create topics. So a lot of Kafka frameworks also create topics to actually make them work. So that can be done through the admin API. And then we have 2 very interesting things. That's the Kafka Streams API, which allows you to build applications that actually are gonna use those streams to combine them, to aggregate them, and produce new streams of data, something that we're gonna use in the demo today. And then we have the Kafka Connect API, and that's all about integrating external systems with Kafka, both as source or as sink. So that means that as source, that means that you take data out of an external system, you create through Kafka Connect Kafka events to it that end up in Kafka. As a sink, it's the other way around. So you consume messages from a Kafka stream and pump them into an external system. Those external systems, they can be databases, things like Elasticsearch, but also like off-the-shelf products like Salesforce and things like that can all be readily integrated with Kafka Connect. So today we're going to use both Streams and Connect in our demo. Now, today we're not going to use just any kind of Kafka. We're going to use Red Hat OpenShift Streams for Apache Kafka. And what is this? So this is actually Kafka as a service provided by Red Hat. So that means that we deliver Kafka brokers, Kafka instances as a service. So this is typically geared towards those organizations that want to get the benefits of using systems like Kafka without incurring the cost and potentially the pain of having to install and maintain what is in the end a fairly complex piece of infrastructure. So with OpenShift Streams for Apache Kafka, organizations will be able to actually consume Kafka as a service. So managed by Red Hat, 24/7 support, 99.95 SLA and stuff like that. And also a very streamlined developer experience, which will make using Kafka as a service very easy. So this service is not built out of thin air, obviously. So it's built on the foundation of the OpenShift Streams project, which exists since a couple of years. It's sponsored by Red Hat, and it's actually Streams is all about make Kafka run well on Kubernetes or OpenShift. So it's the basis of our on-premise offering, which is called AMQ Streams, but it's also the basis of our hosted service. So that means that you can have all the experience that we build up through Streamsy to power up our cloud service. Now, obviously, to build a solution around this, you need a lot more technology than just Kafka. So today we're going to use some other pieces. So first of all, it's clear that IoT devices generally don't speak Kafka, so they generally communicate through specialized, very lightweight protocols like MQTT or others, or potentially HTTP. So that means that if your devices talk MQTT, you need a broker to ingest MQTT, because MQTT is definitely totally different than Kafka. So for this, today we're going to use AMQ broker, which can be set up as a MQTT broker. Then you need to bridge MQTT with Kafka so that what's in the end, what your IoT devices are producing ends up in Kafka. So for this, an obvious choice is using Apache Camel to actually consume for MQTT and then produce to Kafka. Okay. We also going to use Debezium today. So because next to, let's say, your IoT devices, they produce data, but it's generally very lightweight data, because that's how things work. So typically you also have more static data that's maybe in a relational database that you want to use together with your streams produced by your IoT devices. So for this, what we can do, we can use Debezium to create to detect row level changes in the database table and then produce change events to Kafka, and then we can combine those change events with, for instance, the streams that are produced by your IoT devices. And then finally, once you have all this data, you probably want to do something with it. So today I'm gonna use GraphQL, which is a query language, and a server-side runtime, which is which allows you to, in a very flexible way, define your queries. So I'm going to use GraphQL to actually start querying the data that is available both in my relational database and in my Kafka instance. Which brings me to the setup of my demo, and I try to put that in one slide. So the use case today for IoT devices is parking meters, so smart parking meters. And those meters are located in Los Angeles. And this is not a coincidence. This is because I found a data set of parking meters in the public data set of parking meters of the city of Los Angeles that contains data of like 4,000 parking meters. So that was easy to get started with. So hence, smart parking meters in Los Angeles. For the rest, the whole demo has nothing to do with Los Angeles per se, except that we use their data set. So those parking meters, they send MQTT messages about their state, whether they're available, occupied, or potentially out of order, to an MQTT broker. Then we use Apache Camel to bridge MQTT so that the Camel application will consume from the MQTT broker and produce Kafka messages that will end up in a topic called meters in my OpenShift Streams for Apache Kafka. So that's my continuous stream of data. So you have like those 4,000 parking meters continuously send up updates. They all end up in Kafka in that topic. On the other hand, I have a PostgreSQL database with data about my meters. That's the actual data set from Los Angeles, which has the ID of the parking meter, its coordinates in lat long, and also its address. So actually in front of which building the parking meter is located. So that's in a Postgres database. So now I can use Kafka Connect with Debezium to actually get that data out of Postgres and produce change events into a change events topic, which will then contain all the more static data about my parking meters. So I have now two sources of data. Okay, and then I can start using Kafka Streams to start playing around with those data streams. So actually, for that demo, I'm going to do two things. I'm going to enrich the data of my initial stream so I'm going to enrich it with the more static data of my parking meters, and I'm going to produce a new stream of data, which has the enriched data. So now every record in here will not only have the state of the parking meter, but also its location and its address. So that will be an enriched stream that I can then use for other things. And then I'm also going to aggregate the meters. And for this, I'm going to aggregate that by street. And I realized that in the city of Los Angeles, where streets can be 10 kilometers long, this may be not the most sensible thing to do. But the street was something that I had available in my data set. So I decided to use that. So I'm going to aggregate my meter status per street so that I will be able to look up for a particular street, how many meters are available or occupied or out of order. So this is what Streams is going to do, Kafka Streams. And what Kafka Streams also can do is build materialized views out of those topics. So I'm going to have two materialized views, one for the pure meter data and one for the aggregated data, so per street. So, and this can then be used by my GraphQL query engine to actually do, when I say queries here, it's more lookups. So by ID, I can do lookups of my meter data and my aggregated data, combine that with more, let's say, more sophisticated queries out of my PostgreSQL data, and then get like interesting things out of that. And on top of that, I have a UI that actually uses my GraphQL API to visualize some of that data. Okay, so this is actually what the whole demo is about. And let's get this rolling. So let's get my presentation out of the way here. And let's go through my demo. So I have a number of things here. Not that one, this. So most of the parts of my demo I have pre-installed and prepared so that I can just concentrate, and also for the sake of time, so we can just fire up the demo and see how data flows through our system. So this is like the hybrid cloud console, the Red Hat hybrid cloud console, through which I can see my Kafka instances, my managed Kafka instance. So I have one Kafka instance here, which is called IoT meters. It's running on AWS, but that's not so important. It's running in Ireland, and so it's ready. And if I would click on this here, you would see how I can reach that Kafka cluster from anywhere. I also have two topics pre-installed, because for Kafka Streams application, when you create new streams, you have to pre-create the topics. And one way to look at this is through the application services CLI. So I can kind of describe my Kafka instance. So this will give me some data, my Bootstrap server host, and then some other data about it. And then I can list my topics. And you see I have two topics at the moment, IoT meters and IoT meters enriched. So IoT meters, that's where the raw data from my parking meters is going to end up. And the enriched data is for the enriched data stream. I choose 15 partitions and kind of default value for retention. So those topics are empty at the moment because nothing happened until now. Okay. All the other parts of my system are running on a OpenShift cluster, which happens to run under my desk here. And so you see, if you still have that slide that I show you with the demo, you will find most of the components here as well. So I have my AMQ MQTT broker here, which is running. I have my Apache Camel application that's going to bridge AMQ with Kafka, which is not running, but it's ready to be started. My Kafka instance is hosted on the cloud, is represented here by a Kafka connection custom resource. I have my database with my static data. I have Kafka Connect with a Debian connector on top of it, which is also not started yet. I'm going to start that soon as part of the demo. I have my node applications, so one with the GraphQL application, one with my UI, and I have my Streams application, which is not started up yet neither. So, and then obviously I don't have 4,000 parking meters available. So what I do have is a generator, so a small application that will actually simulate those 4,000 meters sending out status information to the MQTT broker. So that's a bit the setup. So now we can start doing things with it. So and start starting things up. So I'm gonna start with my Kafka Connect. My Kafka Connect instance. So my Kafka Connect instance uses, so it's a Kafka Connect, so it has a Debezium connector installed on it. So this is done through a custom resource, so which uses here the Debezium connect to the Postgres connector, because I'm using Postgres, and it has the data pointing to my PostgreSQL database. And what you see highlighted here, I'm particularly interested in a table called meter, because that contains all the data about my 4,000 parking meters. Okay, so if I start up that that Kafka Connect instance, it will deploy also my Debezium connector, and then Debezium will start detecting that there are already 4,000 records in my table and gonna create change events for those 4,000. So to start my Kafka Connect, I'm gonna actually patch my Kafka Connect custom resource. It's set to replica zeros. I'm gonna set it to replicas 1. So, and if I go back here, you will see that now the circle here around my Kafka Connect instance become blue. And when it's dark blue, that means that Kafka Connect is ready, and the Debezium connector will start kicking in. So this is going to take a couple of seconds in the meanwhile. So what Kafka Connect is going to do, it's going to create a number of topics for its own internal usage. So if I look at the topics list, it's still not there. This would take a couple of seconds to start up. It should not take too long. Yeah, there you go. So if I now look at my topic list, you will see that I have like 3 additional topics. Those are internal Kafka Connect topics that were created by Kafka Connect. And normally I also should see soon, very soon. That doesn't seem to work very well. Don't tell me that the demo gods are not with me today. No, there seems to be something wrong here. Because my Debezium topic is not being created. Oh, that's not good. Let's see what's going wrong. Let's look at the logs here. Sorry for that. But I don't see it. It seems that my Debezium instance, my Debezium connector is not being deployed. No, it's not being deployed. So let's see what's going wrong here. What's the best way to look at this? Sorry for that, guys. Demo gods, always the same thing. What can I do about it? Not a lot at the moment. Let's see what. Oh, I can look at the state of my Debezium connector here. So let's look at my installed operators in my IoT meters. I have my EMQ streams. I should have a Kafka connector, and the connector says it's not ready. And why is it not ready? It still says that my connector has 0 replicas, which is weird because it started up. Okay, let's see. That should, I hope, resolve itself, because this is not very logical in the sense that I have a pod. So let's go
back. Is there a way for us to restart the operator?
Yeah, in the meantime, I can do some other things already. So I think it's gonna maybe just slow today. So what I'm gonna do in the meantime, I'm gonna start up my Camel application. So for Camel, so I use a very simple route, which I had here somewhere. Where's my Camel route? Oh no, it's in. It's here. So I have a very simple route that's going to consume. I use the Eclipse PAHO connector, which is a general use MQTT connector, to connect my Camel route to my MQTT broker. And then I'm going to log every message that I get. And then what I need to do, or what I want to do, so I want to have one of the things that Kafka uses is every message can have a key. So obviously my MQTT messages don't have one. So what I'm going to do as part of this route, I'm going to take the ID of the parking meter from my MQTT messages and set this as a Kafka key before sending that to my meters topic, my IoT meters topic. So in my IoT meters topic, all the records will be keyed by the ID of the parking meter. Okay, so that's, I was going to start it up, but I didn't do that. So I'm going to scale that one up. So this is going to start up. So, but in the meantime, let's look at my no, I'm gonna shut down my Kafka Connect again and start it up. So this one. Okay, it should be gone now. Yes, and I'm gonna start it up again by doing the same command, but then set it again to replicas 1 in the hope that now the thing wants to behave, and otherwise I might indeed have to restart the.
Yeah, Gunnar is saying here, Gunnar might know a thing or two about Kafka and Debian. He's saying, what's the status of the connector resource?
It said it was not ready when I looked at it, because it thought that Kafka Connect still had no replicas available, while in reality there were replicas available and the readiness checks were kicking in. So
yeah, not live yet.
Let's see if this is getting any better.
Okay. Maybe you ran out of resources. Yeah, who knows? How much memory are you consuming?
No, I've done it 2 times this morning, so I don't think that's, and it worked.
Third time is the charm.
So. No, that still doesn't seem to. I think I'm going to restart the operator. It's a bit dirty, but unless, let me look at the log first. The resources.
Yeah, if you're a developer and you're watching this, you know that restarting stuff is usually the way that we fix
exactly.
production breaks.
Exactly. No, it's the connector. So let's look at the state of the connector, as Gunnar. So the easy way to do that is through this. my operator, I can look at my Kafka connector, which is somewhere here. And it says state not ready. Because
and while Bernard is trying to fix it, I think it's a very nice thing that we have. Sometimes we have these errors because we can give you a glimpse of how is the OpenShift console. So you have all the information that you need to learn, to see your resources, to debug, and maybe even try to fix the bugs that you have in production. So Bernard is trying to find.
Yeah, I'm gonna. So I have my. Where is my my operator pod here? That's it's not. Why don't? Oh, it's another namespace. I'm sorry for that. So it's in a namespace called MQ Streams operator. I'm gonna kill that pod to see if that helps. So
Fingers crossed.
That should restart immediately.
Yeah, and Gunnar is saying here that so Kafka Connect itself isn't ready. I think the issue is that it's ready and it's not live, right?
Yeah, it should. I think it's live as well. Let's look at this again. Install. So I looked at the connector, so now I can look at Kafka Connect. This says it's ready. Okay, in the meanwhile, what I can do, so we actually gonna miss some of the demo, unfortunately. I'm gonna start the things that I can show. If the things are not resolving, what I can do, I can start my generator. So I'm gonna go back to my topology. I'm gonna start my generator. So this is gonna produce data. So I scale to 1. So, and the easiest way to see what's happening now is if I look at the logs of my Camel application. At a certain moment, I will see that messages are being produced by my meters. There we go. So there you go. So it's like the rate is like 4 messages per second. So you see like the kind of message that has the ID of the parking meter, the previous state, because just starting up, there was no state, the available state, the state at the moment available or occupied, and from time to time, maybe an out of order one and a timestamp. So this is the raw data that is now being sent to Kafka, and that I can verify with, I have like a consumer app that's running as a Podman pod that I can, that's also listening to my meters topic. So if I start that one, it connects to my Kafka instance, and this should now seeing, okay, you see now that I got all those messages with the key. I'm gonna stop scrolling here, a key that corresponds to the ID of my parking meter, and then the previous status, the status, and a timestamp. So now let's see if this no, it seems that this whole Debezium thing is not working, or at least Kafka Connect. I don't know where to put the blame on. Maybe I can do something bold, and I don't think it will help a lot, is actually force a restart of my Connect pod, just to see if that, although what I did was actually and then see if I can tail the logs here. Because otherwise, all the rest, I need my Debezium data, the data, my change events to do my aggregations and my enrichment. So Without that data, there is not a lot I can do here. So let's hope that things kind of get fixed. Otherwise, I'm afraid that so this is Kafka Connect. Starting up. Oh, maybe what I also can do, it's also, I can force actually change in my Debezium connector and see if so this one, edit. So let's get the state again and then save it and see if that changes anything. Oh, that's interesting. Now it says that my Kafka Connect is not configured with the annotation Kafka use connect the resources. I'm pretty sure it was, but oh, that's what I want. Let's verify this. So I'm going to copy that. Okay, and go to my Kafka Connect. Here we go. Let's look at the YAML here. Oh, it's not. Yeah, sorry, that's not that one. Sorry, Kafka Connect, this one. Okay, let's look at the YAML. Let's get it out of the way. Let's get that out of the way. Where are my annotations? It seems, am I missing that annotation? Okay, let's edit. Let's save this. Ooh. Okay. I know what it is. It has to be true as a string. That's better. So let's see what's going on in my topology. I think that should.
Fingers crossed now.
Yes, absolutely. I would suggest that. Yes, I've got it. That's a missing topic. So now I can. So now Debezium kicks in. So and pushes everything to this topic. So I can again quickly verify that with I've got like this another listener application. This one that actually going to consume all those change event messages just to show them to show that they indeed are there. Okay, so you see like for every record you now see like something like that. I can quickly show you how it actually looks like. So you have a before and after, a source. So we are mostly interested in the after part. So the last part of the puzzle now is launching my Kafka Streams application. So I'm gonna launch that. And in the meantime, while it's starting up, I'm gonna show. So Kafka Stream is all about building a topology. And actually I do 4 things in my topology here. So first of all, I'm gonna, based on the data coming from Debezium, I'm gonna extract with a Debezium deserializer, which is configured. I'm going to extract the after part of that change event message. So, and I'm going to key it on a parking meter ID. And this is going to be be stored into a K table, so materialized view. So that's the first part. The second thing is I joined that to my raw meter stream, and I built my enriched data, which you see here, which I sent to my enriched meters topic, which, by the way, this should now be happening now. If I go to this one, so this listener will consume from the enriched data stream. So I should see lots of stuff happening here. Yes, so I see now messages still keyed on the ID, but now not only they have the status, but also the latitude, the longitude, and the address. So this is coming from the data that Debezium got out of the database. Okay, and then what I also do is I aggregate those enriched data by street. So I rekey them by the street, and then I aggregate them. So I count the instances, how many available, occupied, and stuff like that. And I also put that into a table. So basically, that's the last stream here. This one. Oh, it's this one. Yes, this command. So this is now gonna consume this consumer from that aggregating. And you see now things like from on North Venice Boulevard, I have 1 available and 0. Normally I should have more interesting numbers. Olive Street, I have 4 available, 3 occupied, 0 out of order, etc. So this is aggregated by a stream of aggregated data. And then finally I have my UI, and for that, by the way, I need to shout out to my colleague Evan Shortis, who built those original UIs, because I'm totally UI agnostic, if you want. So basically, there is this UI which uses GraphQL underneath. So the first query it does is counting all the meters. I have 4,468 meters. And then I can start listing those meters. So that's another query that's done through GraphQL, and I can start searching for them. Let's say I have like Sunset. This will do a query and show me all the meters that are in Sunset, West Sunset Boulevard. There are like 140 of them. And now if I click on one of those links, I can see the individual data of a meter. And this is where things get interesting, because this combines data out of Postgres with data out of Kafka Stream and materialized view. And this is just a Google Map gimmick. So the thing is, it says NA because there are still, this particular meter did not produce data yet. So let's see if we can quickly find one that did already produce data, like this one. So its status changed 4 minutes ago, and this current status is occupied. So this is coming from my meters stream. And then if I can still have a minute or two, I can do, so what I did not incorporate into this UI, because I cannot do that by myself. So I'm going to use like a GraphQL browser, if you want. So where I can quickly demonstrate how I can query against my aggregated stream data. So let's say I'm going to search for all the streets that have Holly in their name, so like Hollywood Boulevard or whatever. I'm going to limit to 10, and I want the data. I want the name of the stream, but I also want the aggregated meter data. If I execute that query, I have one street that has West Hollywood Boulevard with 4 available meters, 5 occupied, 1 out of order, and it was last updated in this timestamp. If I query it again, you might see those data change. If in the meantime, I think Sunset Boulevard, there are a lot more of that. So let's do Sunset Boulevard. So if I query that data, you see those data are changing continuously, because there are a lot of meters in Sunset Boulevard. So they produce data. So you see like more or less live aggregated data. So that's what more or less I wanted to show. So how you can get data out of IoT devices, combine that with other data, push all that into Kafka, and then start combining those streams to do more or less interesting things with that. So the data has again changed. I have 2 more occupied meters in Sunset Boulevard. So you could do, of course, other things, and maybe do so if you really want to build smart city, do more like AI ML things with the stream of data. But that would bring us too far for this demo. So if I go back to my presentation real quick, so that's basically what I showed you with some troubleshooting on the side, so it was kind of interesting. So that was my demo. So to finish off, I would like to invite you to try out our Kafka Cloud service. So as part of the developer preview program, if you go through that link here at the bottom, you can spin up a Kafka cluster for that will stay alive for 2 days. So you can play around with that. If you want to learn about Kafka, you want to experiment with it, you want to try out things, that's an easy way to get to a real Kafka cluster without having to install it yourself. So very easy. And then finally, I have some resources. So with GitHub repo with the code of everything I showed you. It's a bit work in progress, so I will try to complete it within the next couple of days, and then some links. And with that, Edson, I'm done.
Awesome. And well, lots of tension, but luckily everything works in the end. So that's how cool it is for us to be doing live demos. And we're like out of time, but I'll let you answer one question. And this is an easy question because the answer is probably in the screen. Will the artifacts of this demo be available to download?
Yes, they will. As I said, they're on the GitHub link. That's if you the slides will be published. So the first link, GitHub link. So as I said, it's still work in progress. I have like an Ansible installation playbook that installs everything in one go, but that it needs some love. It's too complicated at the moment, I think. Maybe I'm gonna do something with Helm charts, but the code of the applications at least is there. Okay.
Awesome. Yeah. Bernard, thank you very much for this amazing demo. It was super interesting, and we even learned a thing or two about debugging our stuff when things go wrong during live presentations. So thank you very much. And if you're watching this, thank you very much again, and hope to see you soon in our next DevNation offering. Uh,
Yeah.
Goodbye.
Goodbye.